So makers, here's the code walkthrough for the solutions of the various different assignments, or questions I should say, on the final exam. This isn't as polished as my normal videos because we want to get this out to students as quickly as possible. So question number one, we had Buddy's request, and you could pause this to read through what we're supposed to do, but essentially you wanted to play the jingle sound, and while the sound was playing, we wanted a sparkle, which is just showing a different light lit up for 0.1 seconds, and then turn that light off, and then turn on another one at random. This is what it looks like. So it does that over and over and over again repeatedly. So let's see how we'd go ahead and build this. So first thing in terms of what we need to do is we need to import the board and NeoPixel and time. Digital I/O is used as part of setting up our speaker, and random is going to be used to create our random value. So this is the code that we have in order to set up our speaker on the CPB. You want to make sure that you set the path that you're going to be using for sounds, and you downloaded sounds. There were the Santa sounds in there, so you wanted to change this to Santa sounds. And then this is how we set up our pixels. If you set these up as separate variables, that was great, but you could also have just put in board.neopixel and 10 in here. That totally would have been fine. I didn't tell you to put a brightness level in there, and if you left out the brightness and the auto right equals true, that would also have worked, and the brightness would have been set to 1 as a default. It would have been a good idea to set black and white as the colors. You didn't need red and green yet, but I defined them as colors, so I didn't have to use the numbers. You could put brackets around them, or parentheses, either one would work. And while true, what we're going to do is we're going to play sound. So we're going to call the jingle wave sound. So that's up here. We pass in the wave, and this is the same play sound file that we've used over and over again. So all you needed to do was just copy this. And again, you could have rated your code and copied this. This was a really easy one to do. And the Sparkle code was also something that we had in one of our assignments. So, again, I think the students that did really well had all of their previous assignments. They knew where to find different code that they had written. So you just could have cut out the code that you had already used for sparkling, and we can see what we do here is we generate a random number from 0 to 9. Then we turn on that pixel in white. Then we wait for 1/10 of a second. And then we turn that pixel black. And then, we're going to continue to do that as long as we play the sound. So we're going to get random value, random value, random value. As we get the jingle goes for, let's say it's 3 seconds. I'm not sure how long, but it'll continue to flash. And then what we do when we're done, well, we're just going to while true back again. And it's going to continue to play the 3-second sound again. And while it's doing the 3-second sound, it's going to sparkle over and over and over again, flashing a different random color a different random light that's going to be in white for 1/10 of a second, and turning that off and then doing it again. So that's our first one. Hopefully you did well for that one. And if you struggled with that one, that's probably a good sign to really make sure that you've got down, the work that you had done in your homework assignments. You really want to make sure that you're paying attention to what you've done in your homework assignments. And hopefully you'll do really well on the retake if you're going to be retaking. And with that said, let's head over to question number 2. So here we extend the first build, and what we're going to do here is we're going to detect a shake. We're also to define variables white, black, green, and red. So you already saw that I did that. And after detecting the shake, we should print out "You shook Santa." We'll also create a function called Santa Pulse, and what this is going to do is it's going to pulse in red from dimmest value to brightest, and then from brightest back to dimmest. We want to change the brightness 1/100th of a time. So the brightness value goes from 0.0 to 1.0. So we'll just go from 1 to 100, and then we'll divide that by 100 to get the value that's going to dim out our CPB. And then we're going to go in the other direction. So we're going to go from brightest to dimmest. We don't pause anywhere in between, so we don't need to use the time there. And, again, we want to call Santa Pulse in here when the ho, ho, ho is playing, when we shake. And then once ho, ho, ho is done, we're done pulsing. The pulsing should happen when ho, ho, ho is playing. We should go back to sparkling again. And this is what it should look like. So the shake happens based on the accelerometer. We've already written code with the pulsing as well. We've actually done that several times. So this should have been pretty easy for you to assemble as well. And let's take a look at our solution. So again, we need to import the same things that we did before, but we're going to add Adafruit LIS3DH and bus IO because we use that as part of setting up our accelerometer. So we see the accelerometer down here, so we use bus IO and LIS3DH. So again, this is code you could have just copied out of all of the times we've used accelerometers. We've probably done somewhere between 5 and 10 different things that had used the accelerometer. So lots of different examples in the videos that we did for homework assignments and assignments in class as well. So once that was all set up, well, we still have our sparkle and we still have our play sound function. What we're going to do here is we're going to check to see if we have a shake. So you want to make sure that you're checking for the shake, not for the tap. So again, we specifically had worked with the shake in a bunch of different examples here. So we set up our accelerometer here, and then what we're checking is we're checking accelerometer.shake. You can pass in a shake threshold in here. 15 is what we typically use, but if you had a different amount in here, as long as we're still able to detect the shake, totally fine. If the shake is detected, we print out "You Shook Santa," and then we call "Ho, ho, ho." So this is where we change play sound to make sure that we can either Santa pulse or we can sparkle based on whatever sound we're playing. So the play sound is the same, but what we changed here was while audio playing. So previously what we did was we just called sparkle, but what we do here is we're going to take a look at the file name that we pass in. And if the file name is equal to ho ho ho.wave, then we Santa pulse. Otherwise, we're going to just go ahead and sparkle. And that's, we must be passing in jingle.wave at that point. So, all right, so what does the Santa pulse do? So as long as we're saying ho, 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 we're going to do this. We go up here to pulse. We're going to fill the pixels in with red. And we're going to set our brightness. We're going to go from 0 to 100. And pixels.brightness is how we change the brightness. And remember, that goes from 0.0 to 1.0. So by going from 0 to 100 and then dividing by 100, that means that we're going to go and have a number when we finally set it to brightness that's going to be between 0.0 and 1.0. And actually, this is going to be 99 over 100, or 0.99 is what we're going to get. So we're never going to get to 1.0, but you wouldn't be able to detect the difference in the human eye. I should really have put 101 in here if I wanted to go all the way up to 100. But frankly, once you get above, I think it's 0.65 in brightness, it's just so bright that you really can't tell the differences above that. Then when we want to go back down, so I'm going from 99, actually should have started from 100 up here too. So, just to be clear, so 101 would have been perfect and 100 would have been perfect here. Because remember, we go up to, but we don't reach this amount. So we start at 100 and we're going to go down to, but we're never going to reach -1. So we're going to stop at 0. And we're going to go by -1 here. So this is up to full brightness, and this is from full brightness down. We don't have any weighting in here. I'd reminded you that we didn't need to wait. And then we fill the pixels into black, so we turn off all the pixels. And something that's really important here is we want to turn the brightness back up, because remember, we start at low brightness, and then we go all the way up to brightness, so we're going to do that in red. This happens so fast that you don't even notice this. It would have been totally fine, though, if you wanted to be super cautious in here. You could have set the brightness to 0 before turning it to red, but we don't see any flash there. This happens just so quickly. But once we're done, we turn the color to black, but then we turn it up to full brightness. And the reason we want to do that is because we want to make sure after we are done with our Santa pulse and we've played ho ho ho, then we're going to continue to play jingle wave over and over again until the next shake is detected. So remember, that's what this means to go back and forth here. If we don't detect the shake, we're going to continue to play jingle over and over and over again. And we want to make sure when we do jingle wave, we're going to play the jingle wave, and then we're going to sparkle. And we want to make sure when we start to sparkle up here, when we show the lights in white, that they're going to be in the full color. And if we didn't turn the pixel brightness up to 1.0, the brightness would have remained at the last brightness setting, which was 0, and that's not what we want. So this is the one critical piece to remember in here, just to make sure that we change that for the pulsing. But hopefully you got that as well, and that was question number 2. So question number 3 is very much like the first one. It's just that when we shake, we're going to alternate between ho 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 and Merry Christmas. And ho 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 is going to pulse in red, which is what we had. Merry Christmas is going to be pulsing in green. So I mentioned that you should modify Santa pulse. Initially, we didn't pass any value in there because we just pulsed in red. But now we should accept one input, which passes in a color. So we'll pass red in there if we're playing ho ho ho, or green if we're playing a Merry Christmas. And if we're not playing ho 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 or Merry Christmas, we want to continue to play the jingle sound, and we want to sparkle as we've done before. And again, with all of the builds, you have an example here. So this is what they should look like if it's working. The next shake will be Merry Christmas in green. The next one is Ho 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 in red. The next one will be green, Merry Christmas. So let's take a look at the build. So we have no new imports or components that are set up in here. And in fact, we're going to do the same Santa Pulse that we did before, but we want to do Santa Pulse in red if we're saying ho, 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 and Santa Pulse in green if we're doing Merry Christmas. And we want to change from doing ho, ho, ho to Merry Christmas on our shake. So the things that you'll notice that are different in here is, first, I set up my file name initially to be Merry Christmas. Now, I want the first one to be ho, 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 not Merry Christmas. But when we set file name to Merry Christmas, watch what's going to happen. So this is the same code that we had before. We check to see if we have a shake. And if we have a shake, we say you shook Santa. And then we check to see, is the file name Merry Christmas? If the file name is Merry Christmas, then we're going to change it to ho, ho, ho. So we set the file to Merry Christmas by default. So we change the file name to ho, ho, ho. Else, but we don't get to else right now because we've already changed it to ho, ho, ho. So we skip this, and then we play the sound, which is ho, ho, ho. So, all right, we're going to go up here, and we're going to play the sound ho, ho, ho. And while ho, ho, ho is playing, if the file name is ho, 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 and it is, then we're going to pulse in red. So we modify the Santa Pulse. The only thing which is different in here is instead of saying we're going to pulse in red, we pulse in whatever the pulse color is, and we passed in the color red. So, okay, at this point, we just did ho, ho, ho. The file name is ho, ho, ho. And then we head back in here. We're done. And so now we're going to play the jingle sound. We're going to continue to play the jingle sound over and over again. And while we play the jingle sound, again, we pass a jingle wave up here. And so we take a look here at the file name while the jingle sound is playing. Is the file name ho, ho, ho? No. Is the file name Merry Christmas? No. Well, then we're going to sparkle. And that's the same sparkle that we had before, which is just going to flash the little white lights. So we just check these three different conditions in here. And we'll continue to skip through here until we get a shake. So we'll play the jingle sound and sparkle, jingle sound and sparkle, jingle sound and sparkle until we get a shake. Now, if we shake again, remember the last time we shook, it was ho, ho, ho. So we go in here, we just detected a shake. We printed, you shook Santa. Is the file name Merry Christmas? No. Okay, if it's the file name is not Merry Christmas, it was ho, ho, ho. We're going to update the file name so that it is Merry Christmas. So now we're going to play sound so that it is Merry Christmas. So the file name passed up here is Merry Christmas because we just changed it. It was ho, ho, ho. So that's why we changed it to Merry Christmas here. And so it's going to play Merry Christmas. And while it's playing Merry Christmas, we take a look. Is the file ho, ho, ho? No. Is the file Merry Christmas? It is. So while we're playing Merry Christmas, we should pulse Santa Pulse in green. So we go up here, same thing we had before, but instead of pulsing in red, we're going to pulse in green. And we're down below here again. We're going to jingle over and over again until we get the next shake. When we get the next shake, we go through here and the file name is Merry Christmas. It's the last file name we played. We change it to ho, 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 and then we play sound ho, ho, ho. We pulse in red. So that's how that works. Hopefully you got that. Hopefully that was clear. You're welcome to see me if it's not clear. And, if you're taking this again, hopefully you'll really rock it when you take this the second time. Question number 4 is the red light, green light build. So you've got a servo hooked up to A2, a potentiometer hooked up to A3. Remember, when you hook up the potentiometer, you want to make sure that the power goes to your 3.3 volts. So that's one of the only things that we have that has to have its power restricted. And turning the potentiometer motor should turn the servo. Now you want to make sure that when you turn left, that's going to turn the servo left. When you turn right, it's going to turn the servo right. So actually, when you turn the servo, the angle of the potentiometer is in the opposite direction. So we're going to have to move them both in the same direction. So we'll have to do a change to that. And you might not have realized that until you assembled your code and you realized, hey, when I turn this right, my servo horn moves left and vice versa. You just have to do a little bit more math. And we did this problem in class, so you've actually seen this in action. So again, when you turn to the left, all the lights should light up on left, or should light up as red. If you turn it to the right, all the lights should line up in right. You also want to print out the potentiometer value and the angle as well, so we can see that. And this is what it should look like if we have things working. So we're turning to the left now. You can see that we're red. And when we cross the line, the center line, we turn green. Cross that center line, we turn green, red, green, red. So again, that's how this works. red across the center line. We're not there yet. Not there yet. And then green and then red. So you can see going back and forth. And we're moving the potentiometer in the same direction we want the arrow to move in. So let's see how we would code this up. So the potentiometer has us using analog I/O. We also import Adafruit motor. We also use the PWM I/O as part of using the motor as well. So these are the new guys that we need to import. And again, because you could have rated your old code, you could have taken a look at your motor code and grabbed the stuff that you need for your motor. And you could have taken a look at the potentiometer code and grabbed the stuff you need for the potentiometer. So in terms of setting up our motor, this is the code that we use to set up the motor. And again, you could tweak with min pulse and max pulse, but I'm not expecting that you had to do that. But you could if you wanted to make sure that your potentiometer would point at the 0 degree mark and at the 180 degree mark respectively. But it's if you left that out, it's no problem. It's up to me actually to tweak my particular servo, because everybody's servo may be calibrated slightly differently. But other than that, the setup for the servo is exactly the same. So again, we connected the servo to A2, we connected a potentiometer to A3. Always remember that your power for your potentiometer needs to go to 3.3 volts. And so we call our servo servo 1, we call our potentiometer potentiometer. So when we set this up, we create an object that we refer to, this is as the servo, and this is an object that we refer to as the potentiometer. So when we say potentiometer object, give me the value, that's what potentiometer.value does. And this is going to give us a number from 0 to 65,580. Now the servo, remember the way that the servos move is we go from servo 1, we just say dot angle, and that's going to move our servo in the angle. Now the angle that we're going to move at is going to be from 0 to 180. And so eventually what we're going to do is we're going to get a number from 0 to 180. So what we need to do is we need to translate the number from 0 to 65,580 that we get from the potentiometer so that it's a number from 0 to 180. Now the tricky thing here is the 0 value for the potentiometer is actually going to give us a 180, and it's going to turn to the 180 degrees mark. So I should say if we turn all the way to the left, what we see is that's where the servo is all the way to the left. So when you turn all the way to the left and we get a servo value of 0, we're actually getting 180. And when we turn all the way to the right and we get a potentiometer value of 65,580, that would actually give us if we wanted to move the servo to the right, we want to move to the 0 angle here. So we need to reverse this. So this is how we do it. So first of all, what we want to do is we want to convert the 65,580 to 180 increments as we turn this. So, we don't want to convert from 0 to 65,580. We want to make sure as we turn this, we go from 0 to 180. So how do we do that? Well, we take whatever this value is, which is from 0 to 65,580, and we just divide it by 65,580 divided by 180. So this is the same way we did all of our other numeric conversion in class. And, we did this a bunch of times in class. We also had a pretty detailed explanation video on this as well, how we did the conversion. So, sometimes, you want to convert from 30 pixels in light. So you would put a 30 in here. Different values in here. So we're taking our pot value, we're converting it 65 by 180, and this is going to give us a value that's going to be from 0 to 180, which is the angle we want. Now the thing is, when we're at 0, we're going to get angle 180, and where we're at 65,580, turned all in the other direction, we're going to get angle 0, and we want to reverse this. So the way that we reverse this is simply taking 180 and subtracting it by this value that we get. Because if you think we get 180, we really want to be at 0. Well, if we subtract 180 from 180, we get 0. If we're at 0, we want to get 180. So if we take 180 minus 0, we're going to get 180. So just subtracting from the maximum value here is going to reverse the direction that we have. And again, we did this in our video and in class examples as well. So this gives us the angle that we want, a number from 0 to 180 that's moving in the same direction as the potentiometer. So if you couldn't do the conversion, this is how you do the conversion. You take whatever the pot value is and whatever the maximum value is for your angle, and you divide the pot value divided by the angle, and then you divide this by whatever you get from your potentiometer value. So maximum potentiometer value, maximum angle divided by whatever the current potentiometer value is, which is a number from 0 to 65,580. Now, once we have this, and we divide it by this, you could also just as easily multiply this value by the inverse of this. So 180 divided by 65,580. So either one would work. Now, once we get this value that we need, we want to print out the potentiometer value and the angle value. There are a bunch of different ways you could print out, but I'm using a printf in here, and in between the curly braces is where you can put in the value that you want to print inside of the string. So this is going to print the string pop value, and then whatever's inside of that variable pop value. This is going to print the string angle, and then whatever's inside of the variable angle. And then we just take the servo, which is this object that we created up here, which is our servo, and we say dot angle, which just sets it to the angle, which is the number from 0 to 180. And it's going to move that to whatever position we dialed on the potentiometer. And if the angle is greater than 90, then we want to turn things red. Otherwise, if it's less than 90, we want to turn things green. So greater than or equal to, less than, if you did, less than or greater than, as long as you had it so that you were half of it was red and half of it was green was fine. If you were one number off, I really don't care. Otherwise we turn things black, but there's really no reason why we would ever turn anything black in here. So, you could even use an else in here. That would have been totally fine. And then we say to do a sleep for 1/10 of a second as we're turning the knob. Just the main reason why this is important to sleep for 1/10 of a second is because the print values will go super, super, super fast, but not as fast as the calculation of the CPB. So this is actually going to slow down the CPB so we can see the print values in here, as they roll past. They'll still be very, very fast, but at least we'll keep even with the speed of the CPB. So again, hopefully this was clear on how to do this. This is all of your setup code. Again, you could have rated your existing code in here. So we've already set up our NeoPixels before, but this is how you set up a servo. You want to make sure that you're importing the right things for the servo, this guy here and this guy. We know we need PWMIO. You can see when I double click on this, that's where this guy is right here. And, our servo, if we double click on that, you can see, oh yeah, this guy is highlighted up here too. And then for our potentiometer, we've got analog in, so this is what we have to import for that. And this just sets up our potentiometer object. This sets up our servo object. To get a reading for the potentiometer, we say potentiometer.value. To set the angle, so this is an input. This is an output. So if we want to output our servo object to a particular angle, we just say dot angle. And what we want to do is we want to convert our potentiometer value to our servo angle. So this value here, the input is 65,580. We need to convert it to a number from 0 to 180. So the way that we do that is we just take the maximum of one value divided by the maximum of another value, and then divide that by whatever value we're reading in here. And this is going to give us a number from 0 to 180, but we've got to reverse that. So that's why we take 180 and subtract that value. That's going to make sure that the servo arm moves in whatever direction we dial on the potentiometer. And then we go ahead and we set the angle. And if we are less than 90 degrees, we turn red. If we're greater than 90 degrees, we turn green. And we wait for 1/10 of a second. So hopefully that is clear to you now. And if not, again, feel free to see me. Feel free to see the TAs. But why don't you try going through this code? You can put in print statements. You can put in time sleeps to slow things down too, if you want to see things. But remember what happens. I mean, with while true, we just continue to go through this over and over and over and over again. And we're seeing the different readouts here. So you can see the readouts as you turn the knobs. You can see what the pop value is. You can see what the angle value is. And hopefully that really helps you understand what's going on in this code. That's problem 4. So here comes question number 5, the Steve Harvey Family Feud problem. And you've got your themes inside of the Feud folder, so hopefully you downloaded that and put them in a folder named Feud, and you remembered to set your path to Feud as well. First thing we should do is we should play our theme once and only once. So if you want to do that, the best way to do that is simply to do it before you get to your while true loop. Because remember, the while true loop repeats stuff, but if you do any calls before the while true loop, it's going to play once, and that's going to be it. Then we should write code to show who touched their button first. So we'll check to see if button A was touched or button B was touched. And depending on which one was pressed, well, we'll play the buzzer sound for either one that's pressed. But then we'll also move either in one direction for red or another direction if we're in blue. So one for A and one for B, starting at the center in here. So the idea, excuse me. So the idea is, you can imagine, even though we're pressing button A or button B, we could wire buttons to this too and have them on 2 different podiums. And, depending on whoever pressed the button, it would make a noise, but then we'd also see, the lights light up and point in the direction of the contestant that won the button press. So this is how this should look. So That's the theme playing once. There's button A. There's button B. Button A, you can see we're going from the middle. Button B. Button B again. So that's the way we set this up. Hopefully that was clear to you. You can see as we're going through this. The one thing that's important to remember is if we start at the 15th light, remember we're 0 indexed. So go from the first light is actually number 0, and the 15th light is actually 14. And if we go in the other direction, the 16th light is actually number 15 because we're 0 indexed, and the 30th light is actually number 29. So let's go ahead and see what the code looks like. So the only thing that's new in here that we haven't set up in the previous examples is we're using digital I/O, and we'll actually have to import digital I/O for speaker anyway. So we had that imported, but we're also going to set up the buttons. We hadn't set up buttons before. Remember, when we work with CPB buttons, we use the pull down resistor, and I didn't ask you to do the debouncing, so there's no need to do that. Here's how we set up button A and button B. We say board.button A and board.button B to use the internal buttons that are built into the CPB, so that's what we're using here. So no need to wire up buttons. We sort of took those out of the exam. You didn't have to worry about the burden of making sure you had your wiring correct. Our strip was set up on A1. Again, there are 30 pixels in the strip, so we're on A1 here. Number of lights is 30. And we have our color set up, so red, blue, and black to turn off any of the colors. And the sleep time, I actually told you the sleep time is 0.5 seconds. But you could put that in as a constant or a literal in there. Either one is totally fine. But here we go. So we're going to play our theme before we hit our while true. So that's when it goes ba-dum-bum-bum, ba-dum-bum-ba-dum-bum. So that plays it once. And it's only going to play it once here because it plays it before the while true. Everything in the while true is repeated over and over and over again. We don't want to repeat the theme over and over again, so we just call it before we hit while true. So what do we do down here? Well, we're going to first make sure that the strip is black so that we don't have any colors in it. So we just say strip.fill.black. That turns off all of the lights. Then we just check to see if button A was pressed or if button B was pressed. If button A.value is pressed, then that must mean somebody's pressing button A. If button B.value is pressed, that must mean button B is being pressed. This happens so fast that there's really not a concern that, A is going to press before B if they go down at the same exact time. I mean, your CPB is super, super fast. So, if button B is pressed before button A, this finger goes down before this one is going to be the one that registers. So we don't have to debounce in here, because the first one to touch, it's going to print out, this one, I have a message print out. I didn't tell you to print out this message, but it prints out, dang, you press button A, or yowza, you press button B. I always do this just to make sure I know things are working. So I use prints very liberally in my code. And then what we do down here is we play our sound. So we're going to play the buzz wave in either sound that we play. But we have the same kind of situation we had before. I didn't give you specific guidance in terms to how to set this up. So you might have set this up differently, but if it worked, that's totally fine. So we're going to play the wave sound in both of these cases, but I added an additional value into play sound. I pass in, and in my case, I could have passed in anything like a number 1 or 2 in here, but I figured, well, why not I just pass in the letter A or the letter B, which is the same as the button in here. And so I'm going to go ahead and start playing the buzzer. And while I'm going the buzzer sound, while that is playing, I want to go ahead and I want to do an animation. So if A was passed in, I want to do the red animation. Otherwise, I want to do the blue animation. So what are these two different animations that I have in here? Well, the red animation goes from 14 down to, we never reach -1, so it goes from 14 to 0. So this is the 15th light, and 0 is the first light, so we never reach -1. And we go by -1, so that's how we start at the middle, and we go all the way to the beginning here. And we do this in red. So we start off, that's 14 is going to be red, then 13 is going to be red, then 12 is going to be red, 10, all the way down until we get to 0. We never reach -1. And notice we're not turning off any of the lights. So if you watched the how the video was, let's watch this. These lights all remain on, and we stop at the end, and then we turn them off when the sound is done. So, again, when we take a look through here, so we chug through here, we go 14 and then we sleep a certain amount of time at the end. So I just gave a certain amount of time to sleep, 0.05, and you could have put in whatever value you wanted to make sure that you didn't continue to repeat the animation. That was an important thing, to make sure that you didn't repeat the animation over and over again. And that's great. So, if you press A, you're going to do this animation. What happens if you press B? Well, the blue animation is very, very similar, but instead of going from 14 down to 0, we go from 15 to 30. Now, we never reach 30, so 15 is actually the 16th light, and we never reach 30, so we stop at 29, which is actually the 30th light, again, because we're 0 index, the first light is 0, and just by saying the same thing, strip I blue, that lights that up in blue, and then, we sleep, we go to the next one, we sleep, we go to the next one, we sleep, we go to the next one, and so that gives us the same effect that we saw going in the other direction. So again, you could have set this up a lot of different ways, but I decided to pass in 2 different values into play sound and slightly modify play sound. So I took a look to see what the second value was. If it was A, I called the red animation. If it was B, I called the blue animation. The red animation goes from 14 to 0. The blue animation goes from 15 to 29. So hopefully that's clear as you take a look at this. And again, feel free to put in print statements if you're not entirely sure what's going on at different stages of this. Hopefully now you understand how this one here works, and you've got a Family Feud game set up, so you can play with the family, with your roommates, and Steve Harvey would be proud. So again, this was low-hanging fruit, question number 6. This was exactly like, there's a Jedi in my microcontroller, but instead of swiping up and down, in the Jedi one, we swiped left and right. We also print out, the word up and the word down here, depending on what you swiped on. So you could have grabbed that exact same code and just changed, your numbers. Instead of 3 and 4 for left and right, you could have set them to 1 and 2 for up and down, and just played the different sound instead of the different Jedi sounds that you have there. And again, these were just the riffs from Don Henley's Dirty Laundry. Again, just trying to think about, what could we do with different gestures? So swiping up, swiping down. And I remember this sort of old school song. He was a guy from the Eagles, so it made sense we did something Boston College with the Eagles guy. So let's see how we built this. But again, you could have just copied the code, made 4 changes, and boom, you were good to go. So again, this code is very similar to There's a Jedi in My Microcontroller code. We're passing in digital I/O to use as a speaker, so that the speaker code is not changed. The only thing that's different in here is we've got our sensor now. So we're reading in, we have to import to use that sensor. And again, your gesture sensor is also the one that handles proximity. It handles color sensing too, although we didn't really do anything with color sensing, but we definitely did something with gestures. So this is where you set this guy up. And again, since we're using the sounds in Dirty Laundry, you want to make sure that you change this to laundry. And then this is how we set up our gesture. So when we set up the gesture sensor, we set up I²C. We create an object of the multi-sensor type, passing in I²C. And then we want to enable the proximity sensor and the gesture. So we do both of these things to set up the gesture. And again, the code that you already wrote should have had this chunk of code, so you could have just copied and pasted or read the whole thing in. The only thing you would have had to change if you wanted to, run the Jedi code was you would have had to change the path, one line there. We did 3 and 4 with the Jedi to go left and right. So to go up and down, it's just 1 and 2. We print up and down in here, which is different. And then the sounds are different. So this is the up sound when we move up, and this is the down sound when we move down. And so this is just how we detect the gesture. It gives us a number 1, 2, 3, or 4. 1 is up, 2 is down. We're not doing anything with 3 or 4. If we detect a 1, which is an up, we play the up sound. If we detect a down, we do the down sound. So again, you want to make sure that you set this up properly. You wanted to make sure that you change the path properly. But other than that, same code you should have had. You could have read that in. Low-hanging fruit. Should have been really easy to set up. And if you didn't get this right, many of your classmates got this right. And so, think about your study habits and that will help you hopefully in future classes. Really understanding, okay, what did I do in my assignments? What did I learn in each assignment? And do I know where I could go to access that bit of code that was associated with my learning? And if you didn't have that down, then, you didn't know, wow, I could have just loaded up a file, made 4 changes, and it would have been super, super easy. So, you really want to make sure in future classes, if there's something that you don't understand when you're doing your code, definitely see the professor. I was really happy to meet with folks. Many people stopped by. We had office hours a really unusually large amount in this class, 3 days a week, which normally professors only have office hours on one day. Because I really want to help you out. And, many of the students had been doing really well in class, had been coming for office hours, and I'm really happy to work with them on that. And, if some of the students had said, hey, I'm really not sure about this concept, or why do you do that? Really happy to walk you through that. So don't, sell yourself short. You really want to give yourself every opportunity. And professors, we want you to do well. We want you to succeed. But it's really incumbent upon students to come and see the professor. So hopefully, if you struggled in this class, you know how to, move forward on that in future classes, and hopefully those will go well for you. But this is how we did question number 6. They answered it. And here's question number 7, which was the same as question number 6. The only thing we did was we played the riff, which was the first part of the song, Dirty Laundry, if you never heard that before. And this is just a joke because these are all Eagles songs. You didn't have to know all of that, but the Eagles did the Hotel California, Take It Easy. Boys of Summer is a Don Henley song. So Don Henley is a former singer and drummer for the Eagles. So the only thing that we did here was, if you are playing the up sound, what we did was we started down here in the lower position, which was, when you think, we start up here and we go 0, 1, 2, 3, 4, 5, or 0, 1, 2, 3, 4. So we're going to go from 4 to 0, and we're going to go from 5 to 9 to go up. And then to go in the other direction, we're going to go from 0 and 9 down to 4 and down to 5. And again, you even had your example here to show you, this is flipped, but this is, where the thing was held at the top. So, when we go up, we're going from 5 to 9, or 4 from 0, and then down is going in this opposite direction. So cool. So that's what we had to do to set this up, and let me just show you how this works. Here we go. That's the riff. Play it only once before the for loop, or the while loop, while true. So you see you're going down, move up in blue, down in green, up in blue again. So let's see how to code this. So this is the same code we looked at, same setup that we had before. The only thing that you set up here that you didn't set up before is you've got to have your pixels set up. So we're just working with the onboard NeoPixel. So we have board.neopixel. There's 10 of those. And we set up the colors that we might need. So red. Actually, we only need blue and green in here, so it's totally fine. I set up more colors than I need. There's no points off for that. And we want to make sure that we can turn things black too. So you really needed blue, black, and green. The gesture sensor we set up already in the previous one. And then we have 2 functions here. We'll take a look at the functions in just a bit. Now we play the riff before we hit while true. Again, just like before, if you want to do a sound and have it happen only once instead of repeatedly. So remember, we had the repeated sound with the jingle, but we don't repeat the sound here because we only play it once. So we do it outside of while true. So it's really important. Everybody should understand at this point, hey, what while true is. It goes over and over and over again. Otherwise, we execute our code from top to bottom, and we only loop when we loop. So, again, we get our gesture in here. If we're 1 or if we're 2, well, what are we going to do if we're 1? We're going to print out up. Then we're going to play the up sound. But what I do here is I also pass in a second parameter, the gesture. So look at what I did was I modified the play sound in here. So I have the file name, and I added a gesture in here. And so if the gesture is 1, meaning up, then I show the up lights. Otherwise, if it's 2, I do the down lights, and I do that while playing. So we're either going to be playing the up sound here or the down sound here. So again, if we swiped up, we're playing the up sound. So that's, why we grab that right from here. I could have actually, now as I take a look at this too, I didn't even need to pass in a second gesture value here. Instead, what I could have done is I could have said if file name double equals, and let's see, up.wave, then we want to do the up lights, and then we could have just done else in here, down lights. So that would have been totally fine too. I wrote more code than I needed to. So sorry, I ran through this really quickly before classes. I pulled all this stuff together, but we can even write even more efficient code. And if we did that, we don't need to pass in a second value in here. But again, no points off if you did do something like this, and we're only passing in, one value name here. So if we have up, then we're going to do the up lights. Otherwise, it must be down because we're only doing 1 of 2 gestures here. So we're going to show the down lights. So what are the up lights? Well, the up lights, again, if we took a look at those, we know we want to go from 5 to 10. Actually 5 to 9. So the range is from 5 to 10, which means we go from 5 to 9. We never reach 10 in here. But watch what we do. So we're going to do, you can see here, okay, if I is going to go from 5, 6, 7, 8, 9, so we're going to turn 5 blue. But then we do something very similar to what we did before. So to do its sort of opposite side light as well, we subtract 9 from 1. So we're going to light up 5 here, and then 9 minus 5 is 4. So we light up 5 and 4. And if you take a look at where those are on the map, those are the two bottom lights. Then we wait for a quarter of a second, and then we go through here again, and we're 6. So we're going to light up light 6, and then 9 minus 6, which is 3. So remember, we did 5, 6, and on the other side, we're doing 4, 3. And then if you see 5, 6, 7, 4, 3, 2. 5, 6, 7, 8, 4, 3, 2, 1, 5, 6, 7, 8, 9, 4, 3, 2, 1, 0. So you can see how this, if we light both of these lights up, they happen so quickly. These look like they're happening at the same time, even though, we do this one first and this one second. The human eye isn't capable of detecting this. But we do wait a quarter of a second after we light both of these up. That's why it looks like it sort of lingers when the light is on. So again, if we take a look at the actual build video here, or it running, watch this. So you see how they crawl up together and crawl down together, crawl up together, crawl down together. So the up that we have here again is just, we're doing this light and then this light, but they happen so quickly in here, we don't need a delay. It looks like they're happening at the same time. But then we're waiting. So turn on 2 lights, wait. Turn on 2 lights, wait. Turn on 2 lights, wait. And then once we get to the top, we've waited a quarter of a second, then we turn everything black. And you want to make sure that you do that so that, we start over again. And so it's always important to make sure you turn off all of your lights. So these are the up lights. The down lights are pretty much the same thing, but we're going in the opposite direction. So if we go 9 down to 4, we never reach 4, so we go 9 to 5. So this is like going 5 to 9. And then we do I, or we do 9 minus I. So same thing, but just in the other direction. And we're doing green here instead of in blue. So hopefully that's clear. And hopefully it's also useful too. I actually kind of like that on the fly we can change the code and modify the code and make it even a little bit more efficient in here. You can see multiple ways to sort of set things up. So we started out with 2 values in here, but we could really just use it with 1 value just by paying attention to whatever we passed into our play sound. So cool. Hopefully you understand that. That is problem number 7. And so 8 is Amy Poehler's annoying DJ soundboard. So if you watch Parks and Rec, there are these 2 characters in here that are really annoying morning zoo guys, and morning zoo radio stations in many places that play like sort of top 40. They're really jerky, annoying guys, and they have all sorts of like the same sound effects, like the foghorn and stuff. So the idea here was, hey, could you use your skills with our Gator board, our 12-pad touch board here, to create a sound board? And again, this is another example of you could have just grabbed the existing code that you did and modified it with different names for the sounds, and that was really like sort of super low-hanging fruit to be able to set this up. In fact, I even gave you a Google Doc so you could just like copy these names and put them directly in a list. I asked you to create a list called sounds that had all of these different values in here. And so the idea is if you press on, pad number 0, well, we're going to play 0, which is the Dragonette sound. Pad number 1 is going to play the Benny Hill sound, all the way to pad number 11, which is the 12th one. It's going to play Marv Albert saying yes when you press pad number 11, which is our 12th pad. And you also want to print out, you touched on pad such and such. You want to make sure that you do that. So this is what it should work like when it works. We see we have no lights yet.
Did you get that memo?
Thank God it's... What's going on here? Yes!
All right, so pretty simple build. You get a just taking code that you already had, that you already wrote for this class. And not only did we do this in an exercise, but we also, or in one of your learning assignments, but we also did something very similar to this in class as well as one of our in-class challenges too. So let's take a look at the code. So again, if we take a look at the import code, this is the same actually as we used in our learning example here. The only things that are different is the sounds that we have. So we have special names for the sounds in here, but there are 12 sounds. So when we set up a list like this, remember we can refer to sound bracket 0 bracket. That would be the Dragnet wave string. So that would just give us this string here. Sound bracket 1 bracket would give us the string Benny Hill. Sound bracket 2 bracket would give us the string Boo, all the way up to sound bracket 11 bracket, which would give us the Marv Albert Yes sound. So we want to make sure that we set those up, and it's tough to see in here because my font is so big, but we have a closing bracket that's down here at the other end. So all right, once we have that set up, we have our touchpad set up, and we just call this, again, we're defining an object here, which is the MRP 121 object. It's called a touchpad, just like the proximity sensor is called proximity, just like our servo is called servo 1, and this is an input device. So what we do down here is just we go through the range of from I, and the range to 12 here, this goes from 0 to 11. We never reach 12, so we always start at 0 when there's nothing in the beginning here. And we check each individual pad. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if one of those touch pads is touched, so let's imagine it's the third one. So we wouldn't get anything from 0, we didn't get anything from 1, so we just skip through this. And if it's a third one, then it would be 2, so 0, 1, 2. So if touchpad 2 is touched, so this is just the value would be true. So everything is false unless it's touched. So if the third pad is touched, 0, 1, 2, then we say we touched pad 2, and then we play sounds for whichever one we touched. We're on 2 here, so that would be 0, 1, 2, we would press the boo sound. And then we would continue to go through, and as long as your finger wasn't on any of the other ones, we wouldn't play any of the other ones. And we just continue to go through while true over and over and over again, looking at all of the 12 pads. And it's not until a finger is on a pad that we will detect that, and we will play that particular sound and print out that you touched that pad. So that's how this works. Same code that we had already. We only changed this one line. I think that's the only thing. Oh, and the zoo line. You want to make sure that you change the path so that you're playing the appropriate sound. But that's it. And this one here was 8 points, so it was still possible to get an A even if you didn't get this. But the animations were pretty straightforward. I mean, we already know how to do the rainbow chase animation. So we've already done that in the LED animations file. So when we did that exercise, we went through all of the individual animations, and we also commented out the animations as we did them, so you'll be able to go through them. The one we didn't use was solid, and I wanted to point out to you, hey, after you do the animations, if you want to turn things off, you can't just say strip, fill, black. That's not going to work, and I tell you that. But I said, hey, what you do is you just call the solid animation. It's called the same way, in the same way that you set up the rainbow animation to a particular value. You just do the same thing with the solid animation in here. You call that, and you turn off all the lights. So what this will do is that you'll see it will animate as a rainbow while the sound plays. So we want to make sure that we do, again, when we had the pass value inside of our play sound, instead what we're going to do is we're going to make sure that we run the animation in here, and then once we're done, we're going to make sure that we animate with the solid animation that's going to turn everything black. So this is what things should look like. So this is the rainbow chase animation. You can see that it's changing. But then it turns off immediately, and that's because we're calling the animating the solid black. So same thing. So let's see how we would code this up. So this is the exact same code we had before, but this time we're adding animations. Which animations are we adding? Well, we need to import Rainbow Chase, and we need to import Solid. So again, same thing that we did when we imported Rainbow Chase in here, same sort of structure. We did the same thing with Solid. So once we have this set up, then down here we have to configure our animations. So how do we configure Rainbow Chase? Well, this was something you could have just copied this line directly out of the code that you'd set up. So we already did this in our LED animations, and the other thing we have in here is we set up solid. So in the same way, This was the setup code for Rainbow Chase. I told you, hey, this is the setup code that you do for solid, and we just need to, put this where we sort of create the solid object in the way that we create a Rainbow Chase object in here. We put it in a variable, so you could call this variable anything you want. I happen to call it solid strip, which is the same convention that we used before. So we had chase strip, Rainbow Chase strip, we had like marquee strip, I think, or something for the different animations. So you could call this anything you want, but this is a good one. And then by saying solid strip.animate in here, we just turn off all of the lights. But it didn't matter because all the lights were going to start off anyway. They should start off anyway when you restart things. So what's going to happen here? Well, we're going to press a button and we're going to play the sound. So everything is the same so far from here to here. The only thing that was different was importing and then setting up our animations. And again, you could even have not done this and you still would have had the same result. But this is just, how do we set up the Rainbow Chase animation? Oh, okay. Well, we got to do the same kind of thing for solid. We just give it a different variable name. So now what do we do in here? Well, while we're playing, we simply call the rainbow strip. We say .animate. We call the animate method on the Rainbow Chase strip object. And again, if you took a look at our LED strip, our LED animation, we had all of the code for doing this in that previous file. So, my expectation was that you rated that file and just copied the files that you need to use. And then in the way that we called animate on strip, well, we just want to call animate on, whatever the object is that we created for solid. So it's just solid strip.animate, and that would turn everything off. So if we take a look, we're going to animate, we're going to do the Rainbow Chase while we're playing. And as soon as we're done playing, we're going to animate on solid strip in black, which is going to turn everything off. So that's how we get this result here. Whoops, sorry about that. Let me go back. Rainbow Chase, Rainbow Chase, solid, Rainbow Chase, solid, Rainbow Chase, solid, Rainbow Chase, solid. So that's how this is working in here. So hopefully you got that. Even if you didn't get this right, you still could have gotten an A. And so hopefully you saw that this really relates very closely to code that we've done before. I didn't want to throw you any kind of curveball in here. I think that the one that really sort of stretched your ability to think about, sort of doing new things was maybe this last bit. But I also wanted to make sure, that you didn't have to mess with breadboarding or things that might distract you from actually coding. So, I specifically, at the last minute decided, let's convert out all the things that we're going to do on Arduino over to the CPB. So hopefully you did well on this. And if you didn't, hopefully these explanations are really helpful. And if not, feel free to reach out. So if you do want to retake the exam, just let me know. You get to set the date and the time. Remember, the exam you'll still be able to use the same file that I set up so I have a single page file, or I should say a Google Doc that has the setup for many of the things. And if there's any kind of setup in here that you don't have, you can just let me know and I can put it in that file as well. So you can open up that Google Doc, but you otherwise can't open up existing files. So I want to make sure, even though you've seen the answers, I want to make sure that you really have your ability to write code down. So you want to go through this again and again and again until you can do this cold. And it's just just pull up the notes and go through it until you've got it down. If you don't have it down, just do it again and do it again and do it again. It's kind of like learning a foreign language. But I have faith in you, and hopefully that will really help pull up your grade if you need it. But hopefully, I haven't done the grades yet, but there's a good chance that nobody needs this because I saw you guys really rocking the test. I heard the sounds, I saw the flashing, and I hope you feel like you really learned a lot in this class. So definitely the work that you're going to do at one of the elite colleges in the country is going to be challenging, but we really want to make sure everybody leaves being a CircuitPython programmer, and hopefully you feel like you've got those skills. And I'm really looking forward to your group to your final projects. So I'll see you those on Friday as well, and continue to hack and continue to stay in touch. It's really great teaching you in class.